Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about tuning the Postgres workmem setting for your workload. We'll start with this blog post by Shaun on the Tembo blog from earlier this week. This is a pretty good comprehensive post where Shaun talks about all different aspects of Postgres' memory settings, but I want to focus on workmem specifically and add a few more details beyond what Shaun has in this post. So first of all, workmem by default in Postgres is set to 4 MB. And as Shaun notes here, this is one of the first values that users might want to modify in an attempt to make queries run faster. And oftentimes the effect of this is that if you increase this, Postgres will be able to do more operations in memory instead of having to do on disk, which oftentimes leads to a speed up in a query. Now, if you get this wrong, however, if you set this too high and you have a system with a lot of concurrency, what you will see is that Postgres will crash with a message like out of memory killed this process Postgres. And usually what this means is the Linux out of memory killer went and killed your Postgres process, unfortunately oftentimes the postmaster process, the root of the Postgres process hierarchy, which means that ultimately your Postgres will crash completely if you've exhausted the memory thanks to having too high a work. So one of the ways you can address this is you can use the overcommit memory setting and set that to 2 to essentially prevent the Linux kernel from overcommitting memory. Depending if you have various sidecars on your server or if you want to use swap, this may or may not make sense. But if you have this set, you're much safer to set workmem more aggressively because you don't crash the whole server. But let's come back a little bit to how can we set workmem to the right setting. So one of the most confusing things about workmem, and I had to remind myself again as part of researching this episode, is that as Andres Freund noted in a Mailinglist post earlier this week, Postgres' workmem is confusing because it applies to individual query execution nodes, not the whole query. What this means is that oftentimes for a complex query, Postgres will use multiples of workmem. Let's illustrate this with a specific example. I'm going to create a table locally here on Postgres 17 beta 1. This table has 10 million records and it's 346 megabytes in size. And now I'm going to execute an explain analyze. This explain analyze will select from a table ordering by the first column, and then it reorders that result by a different column. And I have already set the workmem to a sufficiently high number. 458 megabytes of memory are needed here to have Postgres sorted in memory as opposed to sorting on disk. Now, what we want to prove here is that Postgres is actually going to use not just 458 megabytes of memory once, but it's actually going to use it twice because we have 2 sort nodes here. And so what I'm going to do here is I'm going to execute the explain analyze again. And whilst that's executing, I'm going to log the backend memory contexts. This is a bit tricky to get right from a timing perspective, but essentially what this will do is for a running process, it will dump all the current memory allocations that Postgres has. And so what we can see here in the Postgres logs where this is output, we can see that this process uses 951 megabytes of memory whilst the query was executing. We can also prove that this memory is being used by sorts. In the output of log backend memory context, you will see tuple sort and caller tuples. These are essentially both related to the sort operation occurring. Tuple sort is the internal mechanism Postgres does the sorting. And so you can see that per sort node, we are using about 480 megabytes of memory, which does roughly match the memory that Postgres also output here in the explain plan. Now, of course, if you did, a much lower workmem setting, if we did workmem 4 megabyte, for example, what you would see is that the explain analyze now uses the slower on disk sort, but it does also use a lot less memory. So this really is the trade-off here. If I want more performance, now I used 1 gigabyte of memory. Now there are 2 more aspects that I want to mention. The first one is that parallel query will also increase how much workmem is being used. So in parallel query, Postgres allows each worker as well as the leader process to use up to workmem for each of the query execution nodes, which means if you have, for example, 4 parallel workers and you have 1 leader, the process that initiates the parallel query, then you really have 5 in this case, times workmem, which is 200 megabytes in this example, meaning 1 gigabyte. So in this case, that means each of the planned nodes is allowed to use 1 gigabyte of memory if it executes in parallel. The other case to know about is the hashmem multiplier setting. So this setting controls how much memory hash-based operations can use. And the important thing to know about here is that the default as a Postgres 15 is 2, which means that a hash-based operation can use twice the workmem base amount. And you may even want to set this higher if you want to allow more memory for hash operations compared to sort operations for a given workmem base amount. And so the background here is, as Peter Geoghegan noted in this 2022 Mailinglist thread, that essentially the characteristics for how much performance increase you get for a hashing operation as compared to sorting operations is very different. For sort-based operations, whilst you do see a drop-off when things don't fit in memory and Postgres needs to do an external sort, in practice this has a fixed penalty. Whereas for hashing operations, it can oftentimes be the case that you will see drastic performance difference if something can be hashed in memory, versus Postgres might not even choose a hash operation if things spill to disk. And so it may make sense to experiment with using a higher hash mem multiplier, but keeping workmem low. The Postgres documentation recommends going up to 8, for example, in the hash mem multiplier. And so really the motivation here is you could keep your workmem lower whilst increasing your hash mem multiplier to essentially emphasize that hash operations should be fast, but big sorts are okay to spill to disk. Now, let's close with, for a given system, what should I do? Christoph Pettis wrote a good post about this back in 2023, where he essentially said, do not use a formula, because workmem is about the most workload-dependent setting in Postgres that you can find. And so really what you should do is you should do some iterative testing. So what Christoph suggests here, start with a certain workmem setting, let's suppose in the tens of megabytes, then run your system on a realistic production load with log time file set to 0. This will cause your logs to contain messages like, this particular query is spilling to disk with a temporary file of that size. If there are no temporary file messages, then you're done, because probably it's a safe setting, and assuming you have plenty of memory available, you don't really need to change anything. If you, however, see a lot of temporary file messages, you could increase workmem. So the important thing to note here is you could set workmem on a per connection or per user basis. So you might want to give your interactive queries more workmem so they return faster, but the background processes that maybe sort a lot of data, you may want to intentionally keep those on disk so that they don't consume all the memory. And so ultimately, what Christoph is saying, do the iterative process and then find a given workmem setting. If you absolutely must have a formula, Christoph gives a suggestion here. But again, this really is just meant for what's a conservative default that's not a tiny default of 4 megabytes. But in reality, you really should be looking at your temporary files, and you should make an informed decision, potentially using the hash mem multiplier to distinguish between hash and sort operations as well. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.